On this video, I want to go over a couple of concepts you're going to need to understand for the open response test. I've made up a problem kind of similar to one of the word problems you'll have on the open response. So it says a sprinkler in a yard is located at the point 46 on the grid provided. The sprinkler reaches a distance of 10 feet. A crepe myrtle bush is located at the point 97 in the yard, and each grid unit represents 2 feet. So you'll be given a graph, and on this graph I've already located the sprinkler and it's labeled. It is at the point 4, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So the first thing you need to understand is that the sprinkler we're talking about goes in a circular motion and is covering 10 feet from the sprinkler. So that does not mean that your diameter of your circle is 10 feet. Your sprinkler's going around and reaching 10 feet all the time it's going around. And so that is the radius of the circle. So the 10 feet is the radius. This is an important thing when you go to graph that circle, is the fact that each grid unit represents 2 feet. So if you're going 10 feet, you're really just going 5 units on the graph, since every grid is 2 feet. So that's 2, 4, 6, 8, 10. So my sprinkler reaches to this point. 1, 2, 4, 6, 8, 10 here. 2, 4, 6, 8, 10 here. 2, 4, 6, 8, 10 here. So you can roughly sketch your circle if you'd like, or again you can use your compass to help you draw a little bit better of a circle than you can just sketch. So this is the area that the sprinkler will cover, is this whole region inside this circle. So our question, part A, says, can the sprinkler be expected to water the bush? So the bush that we're talking about is the crepe myrtle that's located at the point 97. So if I look on my graph here and I go to 97, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7. That point is really, really close to my circle. So I don't want to go by my drawing and say, it looks like it's outside, because that's really dangerously close. I might not have drawn my circle perfect, and so I really want to do some calculations to be able to prove whether or not my water is going to reach to that point or not. So I know that the distance that the sprinkler goes is 10 feet or 5 units on the grid. And so what I want to know is that distance between my center and that crepe myrtle bush, is it going to be within that 10 feet or 5 units on my graph or not? So I can determine that by finding the distance between our radius of our center of 4, 6 and our bush that is at 9, 7. So the distance formula is something that you're going to need to know, which is the difference between your x-coordinates squared plus the difference between your y-coordinates squared, and then take the square root of that sum. So if I call this my first point and this my second point, the distance between these 2 points would be the square root of my second x, which is 9, minus my first x, which is 4, squared, plus my second y, which is 7, minus my first y, which is 6, squared. So I would have the square root of 9 minus 4 is 5, so 5 squared, plus 7 minus 6 is 1, 1 squared. So I have the square root of 25 plus 1, or the square root of 26. Now 26 is not a perfect square, so when we take the square root of it, since it's an irrational number, we would kind of have to round it off. So to the nearest tenth, that would be approximately 5.1. Now remember, we did that on using the coordinates, and the coordinates are on a grid where each grid unit represents 2 feet. So this is not 5.1 feet. So what this is 5.1 units on the graph. So if I want to know how many feet that is, I have to multiply by 2, and I find out that that's 10.2 feet. So is that within the 10 feet that the sprinkler will reach? No, that's beyond 10 feet. So my answer here would be no. I can't expect my sprinkler to be my bush to be watered by the sprinkler, and this would be the work to support my answer to show it's beyond the 10 feet that the sprinkler reaches. Part B says the homeowners want to plant an azalea bush halfway between the crepe myrtle and the sprinklers. We're supposed to come up with the coordinates of this new bush. So the key word here is halfway. It's a halfway point, which is called a midpoint. So you need to know the midpoint formula, which just takes the two x coordinates and averages them by adding them together and dividing by 2. And the same thing with your y coordinates, adding them together and dividing by 2. So the midpoint between the point 4, 6, and 9, 7 would be adding the two x's, 4 plus 9 is 13, and dividing by 2. And then adding the y, 6 plus 7 is also 13, divided by 2. So that's fine as fractions. If you got that as a decimal, those would be terminating decimals as 6.5 each. So either one of these as the coordinates of the halfway point would be fine. So really, really important that you pay attention to each grid unit being a different number than just 1 foot at a time. Here are some other concepts you're going to need to know for your open response test. You're going to have to know how to write the equation of a circle in standard form. So you're going to be able to have to be able to identify what is the center and the radius from a word problem. You need to know how to graph a circle, how to find the area of a circle, understand what it means if it asks for loss of area. What operation would that involve? Is that addition of areas? Is that subtraction, multiplication, or division? Which one of those operations would you use to find loss? You need to know the 45, 45, 90 triangle rules. You have to know that when you go from the leg to the hypotenuse, you multiply by the square root of 2. If you go from the hypotenuse to the leg, you divide by the square root of 2. And you need to know the central angle to arc relationship, that central angles and their arcs have the same degree measure.